Ladies and gentlemen, good afternoon. Thank you, Paul, for a warm welcome. So I work for the Glasgow School of Art, and it confuses people quite often because my background is pure computer science. And I think what makes the School of Simulation and Visualization quite unique is the fact that we mix up all the different disciplines. So previously, I've always been sitting next to other computer scientists or electronic engineers or that sort of type of person. But where I work at SimViz, I might be sitting next to a 3D modeler, might be sitting next to a psychologist, a designer, product designer. All these different disciplines working together, I believe, enables us to do truly innovative projects and work. So here you can see we exploit the interface between science, technology, and the arts to explore imaginative and novel uses of advanced 3D digital visualization. So today I'm really going to talk to you about computer graphics. It's something I'm very passionate about. I always have been since a little boy. And I'm going to talk about sort of history of computer graphics and virtual reality. And I'm going to talk to you about a number of case studies in virtual reality. And hopefully you can see potential applications for virtual reality within your own work and what you're doing. So let's have a little meander down memory lane. I was lucky enough to have grown up in the 70s and 80s, and therefore I was very much part of the home computer revolution. And this is when the computers started to appear in people's homes. And some of you, this is actually my office, this is part of my window, and you can see my collection of old computers here. Some of you may remember some of these machines. Here we got the old Speak and Maths. Anyone? Bit of audience participation, any remember that one? Speak and Maths, yeah, a few, yeah. Speak and Spell, of course, predates that. These were the first computers with fully integrated speech chips. And Speak and Spell, of course, was made famous with E.T. Then we've got the Atari and the Speckies and Commodores. So the first sort of computer graphics, the first sort of game that became available was a game called Pong. Anyone remember Pong? Yeah. A few of you have got no idea what I'm talking about. So this is for those people that are lucky enough to be nice and young and not remember that. This was a state-of-the-art games of the day. And this was done on some sort of on computers like this. So this is the Atari 2600. It sold about 30 million units. And it was known as Woody because it was made of wood. And then the ZX81, developed by Sinclair Research. When I was at school, we had one of these for the whole school. And I certainly had more than my allocated time on it. It was a wonderful computer, and I'll talk about this in a bit. And you had to build it yourself. Or you could pay a bit more and have it pre-built. But you had this huge plethora of colors to choose from. You could have black or white. And this is an example of the sort of computer graphics that we had in the early 1980s. And this is the sort of games that you had. When I went to college, we were lucky enough to have the BBC. And of course, a Specky 48K with rubbery keyboard. And we were just talking about this. We actually had to load everything up on tape. Yeah? And it took ages to load. And then it would finish loading, and then there'd be a fault, and you had to start again. So I'll sort of touch a little bit on computer graphics, but I'm really here today to talk to you about virtual reality. And virtual reality is becoming more and more ubiquitous. We're seeing it everywhere. I'm even walking down the high street in Glasgow, and I'm seeing mannequins donned with helmet-mounted displays. It's becoming fashionable. If we think of investment, if we look at investment, 2015 saw £700 million worth of investment in AR and VR. 2016 saw 2.3 billion, and 2017 saw over £3 billion worth of investment. So we're starting to see real, proper investment now in developing software and hardware for this technology. Now, virtual reality is not new. And in fact, if we think of virtual reality as immersing oneself into another environment and trying to fool your brain, then actually these beautiful panoramic paintings from the 19th century are early examples of sort of a virtual reality. And these would surround you, these battle scenes would surround you, and you'd feel slightly immersed. Stereoscopic visualization, seeing in 3D, is not new. That's been around for a long time as well. These were around 1860s, these stereoscopic viewers. I've got a beautiful Parisian one. I've brought it with me if anyone wants to have a go on this. You have a left and a right eye image. This is before the movies. This is before the moving picture. This was the Xbox of the 19th century. Okay, and there's my colleague, Matthew. You can see it, you can focus it. And this beautiful scene here is actually set in the gold rush in the States. We'd use a left and right eye camera that takes a picture simultaneously. So the whole concept of stereoscopic visualization and immersion is not new. And that technology actually sort of fell out of interest with the general public as soon as the moving picture came about. In the 1950s, we had a chap called Morton Heilig who invented the Sensorama, which is really a very early example of virtual reality. And this system would enable you to drive a motorbike around the streets of Brooklyn, and it would blow sort of smoke in your face and vibrate the steering wheel, and you'll see in 3D. So it's a type of virtual reality. But the real pioneers in the field, certainly my favorite when I was studying at university, was a chap called Ivan Sutherland, who was a real pioneer in the field of computer graphics. His PhD thesis was called Sketchpad and showed a number of new concepts with geometry and vertices and sort of basic CAD. But what really sort of got me interested in Ivan's work was his work on the HMD, on the helmet-mounted display. This was actually quite dangerous work in this time because it's extremely high voltages right next to your brain. But what Ivan did is he managed to create a computer model that he could look around. So this was the first proper use of a HMD in virtual reality. And as Jaron Lanier states in his recent book, Dawn of the New Everything, none of the predecessors' work, that's the Sensorama that I showed you earlier, none of that included synthesizing an interactive alternate world of unlimited variations that compensated for head motion. So it was a van that was really doing innovative work here. He also wrote a paper in 1967 called The Ultimate Display. And in this paper, it gives an example of how brilliant this person was and how far ahead he was looking. And in his concluding paragraphs, he said something like, the ultimate display would be a machine that can control the existence of matter. Such a display would be, a chair would be good enough to sit in, handcuffs displayed in such a room would be confining, and a bullet displayed in such a room would be fatal. This would literally be the wonderland into which Alice walked. Wow, incredible. What's this guy talking about? He's talking about virtual reality, he's talking about haptic feedback, where you can actually feel something, you can actually get things pushing against you, you can touch surfaces. This is the 1960s. We still can't do that now. But this was the start. Of course, big companies like NASA started to invest heavily into virtual reality. In the early 90s, I was lucky enough to go to North Carolina State University and experience really good virtual reality. It would have cost hundreds and hundreds of thousands of pounds, if not millions of pounds. And I walked into a room with this sort of equipment on. I saw a virtual ball that didn't exist. I picked up this virtual ball that didn't exist. I could feel it in my hand because I had little pneumatic pockets of air that filled up, so I got tactile feedback. I could walk into another room and I saw a big hole, and I could drop this virtual ball that didn't exist down a virtual hole that didn't exist, and I could see it falling at 9.8 meters per second, so it's modeled gravity correctly. And you get this sense of immersion, a sense of really feeling that you are part of this environment. Now, that system cost an absolute fortune, and now we're able to do it much, much more cost effectively. And I'll be discussing that shortly. So these are the old sort of systems of the day, power gloves, I think a lot of people jumped on the bandwagon. In fact, that's why we had this, what I call the VR false start in the 1990s. Who's going to own up to seeing The Lawnmower Man? Yes. Well, not the greatest film. It was actually based on a film by Stephen King. I don't think it actually bore any relationship to the book at all. But what this film did do is it made the general public aware of virtual reality. So all the press suddenly ran to the universities and they said, "This is incredible, virtual reality is amazing. Can you show us your VR?" And we did. I was actually studying VR at the time at Hull University, and we showed them virtual reality, and they were very disappointed with it because it was rubbish. Yeah, and it cost a fortune. They went, "That's nothing like the film." It's like, yeah, it's nothing like the film. We still need to do a lot of development work, but the work still needs to be done. You still have companies like Nintendo jumping on the bandwagon, creating games like the Virtual Boy, which is all in red. Why? Because red LEDs are cheaper than any other LEDs. But one has to ask about health and safety here. You had lots of young kids putting on these HMDs, not much sort of health and safety in those days, and they're wondering why everyone's feeling nauseous and sick. And you know what kids are like with computer games, they never want to take them off. But anyway, it has to be said that this was a complete failure. Let's fast forward to 2011. An electronics whiz called Lucky Palmer, who used to enjoy fixing people's mobile phones in his garage. And of course, think of your mobile phone. Think how much that display technology has improved in the last 15, 20 years. It's incredible. I remember the old Nokia bricks. They're coming back now, actually. They're quite becoming fashionable again, because people don't want to be interrupted all the time with messages and emails, etc. But think of how incredibly advanced our display technology is now compared to what it used to be. So what Lucky did was he took mobile phones apart and he started to create his own helmet-mounted display. He turned that into a company called Oculus Rift, and a couple of years later he sold it to Facebook for $2 billion, which he pocketed. $2 billion. So now we're getting a lot of investment again, and a lot of that investment comes, what I was talking to you about earlier. So last year, over £3 billion worth of investment made. What can we use this technology for? So I'm going to give you a few examples. There's a whole plethora of activities we can use VR for. I'm going to touch on a couple of these. The obvious one is games, of course. And what I would like to do is just jump back and again show you how much technology has evolved over time. So the ZX81, if you remember I showed you this. This is a scary monster from 1981. Let's have a look at a scary monster from a few years ago. There you go. You might not be able to see that because the lights are on, but that's Alien from the 1979 film Alien by Scott Ridley. This is now terrifying, okay? This isn't really terrifying. This is terrifying, and what makes it even more terrifying is if you play this in virtual reality. I can't do it. It's too scary. Let me give you an example. So this is Jessica. She's got a helmet-mounted display on. My point here is how virtual reality can be so immersive. She's playing this game, so if anyone's seen Alien, it's very similar. She's trying to escape. She's not running around shooting everything. She's trying to escape from this alien species which is trying to track her down. And she's hiding in a cupboard. And when she's climbing up a ladder, she'll look up. She's looking around. She'll do this. And of course, the computer will update accordingly.
Oh my God. Oh no. Oh no. I don't want to do it. I don't want to do it. Oh God. Spin up, spin up, spin up, spin up.
Go. Go, 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 go.
The reason I move to the next slide is because she starts swearing at that point. So. Education, of course, we have huge potential in this field. And lots of exciting work happening here. We've got Google Expeditions, which is a big focus for Google to actually enable students to be able to move away from textbooks and two-dimensional photographs. And if a child wants to go to China, the Great Wall of China, they can go there in virtual reality. They can go to the moon. They can go to the bottom of the ocean. They don't need to be limited to photographs.
Pick up your devices and look in your cardboard.
What is that?
I see a shark.
It allowed us to go somewhere we wouldn't normally be able to go.
Are we in China?
This is the Great Wall of China.
We got to see the place itself, so we could actually understand what she was talking about.
How long would it take to walk the length of the Great Wall of China? So much more enriching than just showing them a picture or just having them read about it.
This device can actually make us go to places that we've never been before.
It brings the lesson to you.
You have to see it for yourself to believe it.
There's so much other places to see, so you know that it's never going to end.
I always love it when you see kids experiencing virtual reality for the first time. There's something special about that. I'm also delighted to say that I saw in the news that a Scottish council is the first in the UK to give virtual reality headsets to 30 primary and secondary schools. So that's wonderful, wonderful news. That's Renfrewshire. So they've made the council have made a £250,000 investment to get HNDs into the school. What's really important is that you don't just dump the technology in the schools. Right? You need planned lesson plans, and you need proper training to teach people how to use the virtual reality. So other applications, of course, in sporting. This is what I was talking to Simon Mayo about last week. You know, we can actually have the best seats in the house now in virtual reality. I can sit next to a friend from Spain and watch a basketball match or a boxing match or whatever it is. So huge potential there for real-time streaming in virtual reality. Medical visualization and training. This is something Paul touched upon. This is an area that we focus on at the School of Simulation and Visualization. For several years, our team, and working closely with Paul, have been developing a very accurate three-dimensional model of the human body through dissections of a male cadaver, laser scanning, MRI, CT, photorealistic modeling. Of course, the head and neck is a very complex part of human anatomy, so if I can actually get inside it and move around and pull parts of the skull apart, it's a much more intuitive way and a better way for me to study and learn. We can take the same data set and teach people how to do injections. So you actually feel the needle, and we're using haptic devices now. This is part of virtual reality as well. Of course, one of your senses is touch. With haptic feedback, I can actually feel the needle going through the gum. And if I go too far, I'm going to hit bone. And I know I've gone too far. Previously, dentists used to practice on each other. That's illegal now. Or they'd use tangerines, this is what I'm told. So using this sort of system is a much better way of learning. Here's some examples of the detail of our models that we've created. And again, we live in a 3D world, so let's interact with it in 3D. One of the problems with virtual reality is that you're tethered. You have an umbilical. But with our new ZHP system, which Intel have kindly donated to us, we're no longer tethered. So we can now walk around an environment without feeling that we're attached to something. So this is Stefania at work, and she's interacting with the human body. She can move it around, she can go to any place she wants, she can pull parts of the human body apart, she can get the correct names for it in Latin, different terms. And this equipment doesn't cost the earth. If you think back to the 90s, we're talking about hundreds and hundreds of thousands of pounds for VR equipment. It's so much cheaper now. And it's so much easier for us to actually create content. Content creation is really important. It comes back to what I was talking about with the schools. There's no point giving schools all this equipment, even if you train them how to use it. It's all about content. What content can we provide? Here's an example of how augmented reality works. So seeing the real world. So medical visualization has huge potential within virtual reality. And indeed, in 2016, we saw the first ever virtual reality live operation, enabling members of the general public or medical students to stand next to a leading surgeon and watch them remove a tumor. How good is that if you're a medical student? Again, forget the books. I can stand next to a leader in this discipline and watch them at work. I have no idea why the surgeon is wearing a helmet-mounted display. It makes no sense. Yeah? It's actually me at home wearing the helmet-mounted display. The surgeon, I would run a mile if I opened my eyes and saw a surgeon wearing a helmet-mounted display, because he's not going to see anything. Dangerous sports as well. I was lucky enough to develop the world's first paragliding simulator about 12, 13 years ago with a good friend of mine. When you're in a stressful environment, your decision-making breaks down. You can be taught to, for example, if you think of skydiving, you can be taught on the ground what to do if you have a failure with your parachute. And you can go through it 1,000 times and you get it right every time. But if you're falling at terminal velocity and you've got the wind in your ears and you're spinning, you forget everything. Why? Because your decision-making is broken down, because you're stressed. So how can we improve this? We can improve this by training people in a similar environment to the real thing. So, for example, with skydiving or paragliding, if I put, when I learned to skydive a long, long time ago, when I learned, they put photographs above my head, and they say, what would you do in this situation? And they put a photograph above your head. And you go, oh, I'll do this, this, and this. That's not immersive, which is why you had a lot of fatalities, because people got so stressed. But in virtual reality, I can put the sound of wind into your ears. I can model everything accurately. And that's the good way of training. What's very important, however, is that you train people correctly. Because if you train people with the wrong system, for example, if you have a stall point here or there, and in reality it's here, then you're going to get a lot of people falling out of the air because they've got this ingrained user model. It's like when you change cars and the indicators are previously on the left, and now they're on the right. You keep doing the washers. I had a good friend who was a dentist, and he learnt to drill on wooden models of people's teeth. It's a long time ago. And he said to me that when he's drilling the wood, every so often he'd blow to get rid of all the shavings. And he said when he started working with real patients, there was a real temptation to blow. Because he built up this user model of working with the wooden model. So it's very important you get it correct, especially with safety critical systems where life is potentially in danger. Here's some more work that we've done. This is for the decommissioning of a nuclear power station, which takes about 60-odd years to decommission a nuclear power station. All the electrics are off. How do we train people to walk around an environment where there's no lights? Well, we can do it in VR. So we can scan in a site, we can model it accurately, because it is actually quite frightening. But we're using a helmet-mounted display, we can train people what it's actually like. So it's a very effective use of health and safety. So this is Bruce, who's using the system here. He's using a HTC Vive. These systems cost about £600. And of course you need a powerful computer to drive it. But again, it's feasible for us to invest in virtual reality. It's no longer a risk. It's no longer a risk for you as academics, researchers, or with your companies to invest in virtual reality. This is some other work we did in Trinidad. So this is a ship, and we can use virtual reality and 3D computer graphics to train people how to fill up a tanker with LNG. Because it's a very dangerous process, but we can actually train people using virtual reality. It's the same things with an oil refinery. We can model fires. We can say to people, okay, what would you do if there's a fire here? Which valves would you turn off? This is all using games technology. This is what some people refer to as serious games. I don't really like that term, but this is what people mean by serious games. So we're using games technology in order to do sort of serious applications. SimViz have recently branched into the area of pharmaceuticals. And this is a very interesting area for us. We're quite excited about this. So this is using virtual reality to monitor your experiments. So crystallization, filtration, different processes in pharmaceuticals. All this equipment, we've created three-dimensional models, this sort of digital twins. And we can actually enable someone using virtual reality, let's say they're in Australia, they can watch their experiment. They can go and visit their experiment. How's my experiment doing? We can augment the equipment with other data. So for example, we can see temperature of this system here, this crystallization system, and if I bring up a virtual iPad, I can get various temperatures on the hardware. There we go. And of course I could do that in augmented reality as well. So I could actually have special glasses and I could look at this piece of hardware in real life, in reality, and I could augment this color onto the system. So because the data's already there, the data's flying on the network. Often it's just about collating all the data together. So this is a prototype that we've recently built, and we've just got quite significant funding to take this to the next stage. Let's have a little think about how we can use virtual reality if you're coming from an artistic domain. So from an artistic perspective, the options and opportunities are limitless. What's interesting is there's a lot of traditionalists in fine art that absolutely hate this. You know, they very, very much want to stick to two-dimensional planar surfaces and paintbrushes. Okay, but this does open up a number of opportunities for us in the arts. So a couple of years ago, I gave a talk to the BBC, and I entitled it VR the good, the bad, and the ugly. And I kind of play devil's advocate here because everyone's saying how great VR is, how great VR is, how great, and VR is great. But there's still lots of problems which we need to solve. One of them is if VR is successful, if you have been immersed into a virtual environment and you feel part of that environment, which is good, then you forget about reality, which is what you want. But the danger of that is forgetting about reality can have very painful consequences. And in fact, I predicted about 6 months ago that we'd have the first fatality in virtual reality in the next 2 years. And that will come through either someone who is cardiovascularly vulnerable, and you only have to look on YouTube and see how scared people can be in virtual reality, or someone who runs through a glass door or falls into a glass table. It's A&E departments are seeing a large number of instances now in virtual reality. So we're seeing a lot more of things like this.
You almost don't forget the light. Oh, shit.
Because people forget about reality. So the VR is really good, it's working, but it's also extremely dangerous. Here's another example. This is a game called The Climb, and this gentleman here is rock climbing, and he's totally immersed within his virtual environment. So he thinks that there is a rock face directly in front of him. When he's climbing, he's getting some sort of tactile feedback on his hands because he can feel the digital rock. But in reality, there is no rock in front of him.
Oh my God.
So these are legitimate dangers of virtual reality. How do we solve these? How can we get around some of these problems? Well, you may laugh, but it's really good. About 8 years ago, or when was it? 18 years ago, goodness. I was in the States at a SIGGRAPH conference, and they had this Japanese professor who had invented this system for being able to walk around a virtual environment, because that's the big problem here, is walking around a virtual environment. And he had this system whereby, think of carpet tiles, which I think are 60 centimeters across. So imagine robots which are carpet tiles, and as I take my foot off one carpet tile, I go onto another robot, and then as I take my foot off the back one, the robot drives round to the front, and then it drives round to the front, and it keeps dragging you back to the center of the room. That was the technology back then. Needless to say, it didn't quite work. Cost a fortune. This is actually quite a good system. So you wear these sort of Michael Jackson slippery shoes, and you can actually sort of do this. So your brain is saying that you're actually running in virtual environments. Now, of course, you're not going to run into the window because you're stuck here. So this is around $700, so it's quite a good system. Of course, you can see the gaming market is huge. The nice thing about this is my brain is saying I'm actually doing something physical as well. So if you're running far, you do actually feel quite tired doing it. There's something called the Omni Infinity, which is it's a catapult center in Milton Keynes. I had the pleasure of having a go on this system. This does feel quite odd when you're doing it. It takes a while to get used to. What you can't see is that goes about 4 or 5 feet under that surface as well. It's extremely, extremely expensive system. I was laughing at that point because they said that no one had ever fallen over, and I thought he was going to be the first. So, a couple of other things I want to talk about. We still don't know what the long-term effects of virtual reality are. And it's very easy to get a 3D stereoscopic image working. but it's very difficult to get one that's truly accurate. And because of this, we often get headaches, can feel nauseous, because everybody's eyes are different. Everybody sees slightly differently. And virtual reality often is about faking the visuals. One has to ask, should young children be using virtual reality? And in fact, if you look at the guidelines with all the companies, they all say that you should be over 13 years of age if you want to use the equipment. I think it's only Google that don't actually give an age restriction on it, but they say you should only do it for 1 minute bursts and you should have an adult with you. But we should take care with putting helmet-mounted displays onto young children. This is where your brain is developing massively as a young child. I find it quite amusing because to my young son, I will say, get away from the television, you're sitting too close to it, which I think is, everyone says that, don't they? But then I'll put a helmet-mounted display on myself where the display is right here. So, but with all seriousness, we need to be careful. And a lot of the marketing is directed at children. Things like the Viewmaster. Does that look familiar? If it doesn't, that will. Remember them? That's a type of virtual reality. It's a type of immersive environment. This is the new version. You put your phone in it. That's the old version. So, as recently as 10 years ago, children would only have been in front of the TV. Now they're in front of the TV, and then they go to their tablets. Then they go from their tablets to their mobile phones. Then they're going to go from their mobile phones to their HMDs. In the last 30 years, we've seen short-sightedness in children double. Why? Because everything's at a fixed focal point. Everything's at a fixed distance. I'm just focusing on this. All of us do it. There's something I'm reading about at the moment called wexting, which is texting while you're walking. Again, a lot of people doing it. You're just at a fixed focal point, and it's really bad for your eyes. When my first job was a computer programmer in the offshore industry, and I was programming for ridiculous lengths of time, my eyes just focusing on one point, and they just stopped working. And one day at work, one of my eyes, which is odd because you think they both fail simultaneously, but one of them just stopped working. I had to go outside, and it took about an hour before my eyes started working again. It's not good for us. Let's just have a little look at and a guess at the future. There's a new film coming out tomorrow, and it's called Ready Player One. I'll just let that run while I talk. I'll keep the volume off. Unlike The Lawnmower Man, which came out, say, 30 years ago, the general public now are much more aware of virtual reality. And also, any one of us can go out and buy equipment, buy VR equipment very cheaply. So we can actually have this equipment at home. So it's a very exciting time in regards to virtual reality. But we need to think about what improvements do we still need to make. Your main sensory input is vision. I think over 50% of your brain is processing what you're seeing. And the other senses, haptics, taste, smell, vestibular, are all very complex, but the main one is driven by vision. Taste and smell are incredibly difficult. It's too hard to solve the taste and smell problem in virtual reality. Companies aren't really even investing money in it because it's just too difficult. It really is. They're very linked as well. And in fact, if you've had a laryngectomy, if you've had your larynx removed, that affects all your smell and taste. And often people who have had a laryngectomy, they not only lose their sense of taste, but they also lose their sense of smell. So we forget taste and smell. Hearing, okay, we can do basic stuff. We need to get it right. So if I drop a feather in virtual reality, I don't want to hear a big thump. It needs to be correctly modeled. Haptics, extremely difficult. Very, very difficult to model. but the vision is one where we put a lot of focus. So where are we at the moment? Well, most helmet-mounted displays, you're getting about 110 degrees field of view. So my point with this slide is we are no way near, with the quality of virtual reality equipment, we're nowhere near what your body can absorb. I can see in about 210, 230 degrees field of view, so we're nowhere near it. The image quality, these are pixels per degree. Well, most HMDs looking at 10 to 15 ppd, but our eyes are really good. In 20/20 vision, you're looking around 120. Variable depth of focus, this is a big one. All HMDs are a fixed point, fixed depth of focus, but in reality, I focus on this point, I focus on this point, I focus on that point. Types of lighting, we can pick up different types of lighting. And who wants to wear a helmet-mounted display anyway? Who wants to wear a HMD? No one, they're too heavy. I'll wear that if I have to. Something like that. The problem is that if I try and increase the field of view or the resolution, it has an inverse relationship to the ergonomics. So if I start to increase the resolution, then everything starts getting bigger. So what we need to do is we need to be clever and say, okay, so where's the eye looking? I start to do eye tracking. Because I don't need high resolution in my periphery. I don't think I even need color in my periphery. So if I know where I'm looking, I can put that in high resolution, and I can drop the resolution in the periphery. But this is still a big problem with VR. Haptics as well is extremely difficult. Okay, if you think back to what I was talking about, Ivan Sutherland, where he's talking about a chair being good enough to sit in, handcuffs being confining, and a bullet being fatal. Let's forget that, the bullet being fatal bit, but certainly chairs being good enough to sit in. How could we do that? How can we build a system? Is it going to be a suit that can go rigid in certain places so I can sit? And then you've got big differences between sort of tactile feedback and the feeling of touch and the delicate elements, and then force feedback where I need resistance. Right now I'm leaning on this table, so this table is exerting a pressure on me. So virtual reality would need to do that as well. It's extremely difficult. So I'm finishing off now, and what I want to say is VR is not the snake oil panacea. VR is not our solve-all solution. A lot of people think it is, but it's not. And we need to avoid jumping on the VR bandwagon just to be gimmicky. I remember when 3D computer graphics became popular, and you saw a lot of news companies moving their weather to 3D. And it was atrocious. The weather is not a three-dimensional problem, it's a two-dimensional problem. I need to know what the weather is at eastings and northings, X, Y. I don't need this cloud and rain coming down, and I can't see where the rain's landing. And that's what it was. In fact, Scotland had it really bad because it was London-centric. And when you had I think it was BBC. It was BBC News, and they had the south of England all big, and because it was in 3D, you had little Scotland up at the top. Who knows what we're looking at? We don't need 3D in some instances. The same with VR. So don't try and force your virtual reality technology into a circular hole. But what you can do is you can prototype, you can do tests, and see if it is going to work. But it's not going to work with everything. So Michael Abrash, who is the lead scientist at Oculus, recently said, VR is a vast space waiting to be explored, but there's still decades of innovation and challenges that lie ahead. And what I'm seeing now, and I've been working in this field for a long time, is finally I'm really seeing real applications and real benefits of using virtual reality. And it's up to us to see how we can use that in our in our everyday lives. And finally, just a little plug for a training course that we run in Glasgow. We run a one-day CPD event, and you can get information on it up there. It's a non-technical course, and it enables you, like managers or people that want to know more about virtual reality or augmented reality, and it's for people that want to know more about what the technology can do and get hands-on experience with the technology. So we've got all the latest gear, like the backpacks you've seen. You can see demos of it, and it can give you ideas about how you can potentially use this technology with what you're doing. Next course is on the 8th of May. And that's me. Thank you very much for listening. Cheers.
Thanks very much, Paul, for a fascinating talk. It takes me back to my childhood with a ZX Spectrum 128K+2, and it had a tape deck in it as well. You had all the... That was posh, very posh. Is there any questions that we have for Paul?
Yeah, I know you said that virtual reality is not the answer for everything, but do you envision application, for instance? I'm sorry. For instance, virtual reality is a rejected practice to meet the requirements of governments. Example, static and fatigue testing in the aerospace industry. It's been explored but rejected. They do build a full bird and subject it to static and fatigue because of government requirements. Do you think there will be an application in the future? Would it answer that question?
Within governments?
Yes.
Yes, the answer to that is yes, because we've already done quite significant work in that. So let me give you an example. BAE build ships, and when they want to prototype, let's say the control center of a ship, believe it or not, they build it out of wood. That takes time. So we built a prototype system where we did it all in virtual reality, which enables people to actually walk around, and we can put people of avatars, which are people, of different heights, and we can model the room exactly like it's going to be on the ship before they've even built it. And we can say, do you know what, if we put a person sitting in that seat with an average height, you're no longer going to be able to see that screen there. Or you're not going to be able to take someone out on a stretcher and take them out of the ship. And we did all of this work, and the wood was still on the pallets on the water. So they hadn't even got the wood off the pallets, and we'd already built a virtual reality prototype of that ship room. So it can be used extremely effectively for those sorts of government projects.
Okay, thank you, but I have a subsequent question, follow-up. How would that be different from simulation then? I mean, I'm not clear on the difference between virtual reality and simulation. Okay. It sounded to me, the example you just said, it's more simulation to me, to figure out how the system is going to behave or building the ship, rather than...
Okay, so in that example, that is not simulation. Okay, as in sort of doing fluid dynamics and things like that. Okay, so all we're doing there is we're taking an accurate three-dimensional model of a ship, of a control center within a ship, and enabling people using games engines to be able to walk around it. Okay, if we were then going to say, okay, now let's say there's a fire, how fast is that fire going to spread? Then we start to move into the simulation domain. Okay, so then we're going to say, okay, well, the fire's going to spread here, and people are going to behave in this way, and they're going to run out in this direction and that direction. That's when we can start to involve simulation. There's no, that's still very effective. So the virtual reality is very much sort of the visualization, the visual side of things, but works very well when you couple it with simulation.
Okay, thank you.
I think if I can ask a question as well, Paul. Where do you see virtual reality, or do you see virtual reality actually being used within the higher education sector? Because looking at these pictures and the problems that can happen because it is so immersive, do we have our students in all of these playpens and reins that are held in? How do you think we're going to use that in teaching spaces and learning spaces in the future?
It's a very good question. I think One type of visualization is collaborative visualization. So it's where we can actually see people that we're working with, see people who we're learning with. If you do it in augmented reality, it happens naturally because I can already see everybody around me. But we don't need necessarily to be running around. We can be sitting at our desks with helmet-mounted displays on. I mean, one thing I haven't mentioned today, because I wanted to kind of stick to virtual reality, but augmented reality, of course, is a very exciting subject as well. And that's really taking off at the moment. We're not quite there yet. A lot of the multi-billion pound of investment is actually in augmented reality. And there's a company called Magic Leap who've got some technology. It's very hidden away at the moment. We're yet to see what comes out. But then one hopes that we're going to start to see technology on the lenses. If you remember Google Glass, which was Google Glass is actually a very good product. The problem with Google Glass was the general public wasn't ready for it. I think the real advantages in the future, there's a place for VR and there's a place for AR. And I think when AR really starts to take off in the next few years, then we're probably going to see more augmented reality teaching applications.
I think we have a question down here. Thanks, Mihai.
Hi. In schools, when children use it, do you worry then that the real life experience will be rather disappointing? Because after all, if you go to the Great Wall of China, it could be foggy. I don't suppose it's ever foggy in virtual reality. And the other thing,
Scotland's always sunny. Isn't it?
exactly like the tourist brochure.
Yeah.
And then the other thing is that if Oculus was bought by Facebook, how much data are these big companies collecting on you while you are using virtual reality, or do they not collect any? Is that not how it works?
It's a very, very topical question at the moment. Okay, so let me answer the first part of the question. So there's a certain advantage to virtual reality because let's say there's a beautiful stepwell in northern India, and we've created a virtual model of that with our colleagues at Historic Scotland. And I can pretty much guarantee that nobody here has actually visited that stepwell in Gujarat in northern India, maybe a couple of people. But in virtual reality I can. So I can visit it. Now, the advantage of virtual reality is actually I'm also able to remove myself from the planar surface upon which I walk, so I can fly. So if there's some beautiful, intricate, ornate carvings of Hindu deities, I can actually fly up there and experience them in that way. Like here, these windows, I can actually fly up there and look at it. So there's certain advantages. Of course, it's never going to be like the real thing. Maybe one day it will be. From a visual point of view, it probably will be. But from a tactile and force feedback mechanism, it won't be. It's just too difficult. Maybe hundreds of years in the future. But we're already able to create. I can show you computer-generated images, and you cannot tell me if that's real or if it's fake, if it's computer-generated or if it's real. So, there's advantages and disadvantages. But if a child is given the opportunity of a very realistic immersive experience on the Great Wall of China, that's much better than the textbook. With regards to monitoring, people are listening all the time. People are gathering data all the time. In 1987, there was the McCormick report which came out, and that was about US government needing to invest, or request the US government to invest because of all the fire hoses of information. And what was happening was new weather systems, weather satellites, medical hardware was gathering so much data that it was being warehoused, and we didn't know what to do with it. So it's how do you actually visualize and understand that data? And we collect so much data all the time. It's very topical what you're talking about with Facebook. If you've got Alexa at home, is that listening to me? Is Alexa listening all the time to all the conversations in the house? Who knows? Who knows who's listening to you? Do you have a little bit of sellotape over your camera on your laptop? I do. Who knows who's looking at you, watching you? Who's hacked into your home cameras? Yeah, I've got a little puppy at home, so I've got a little webcam that's looking at him. So I can see what she's doing. But who else is looking at that? there's a website in Russia you can go to, and you can see there's about 1,000 different people's home real-time views because hackers have gone in and hacked into everyone's cameras. So people are collecting data all the time. How they use that, we don't know. I mean, if I was to think of it from a constructive, positive way, and coupling it with augmented reality, I would say, for example, if I wear glasses and someone comes in for a meeting, then my glasses will automatically scan that person, do facial recognition on them, and put their name above their head. Not only that, but it will tell me what their wife's name is and the topic of the last conversation I had with them. That will happen very quickly, actually. But then that leads us to other problems, because then you lose the ability to remember anything. In the old days, before writing, in a long, long time ago, we used to remember things in verse, in song. Then we were able to learn to write, and as we progress and as we evolve, we actually have less and less requirement to remember, because my mobile phone tells me everything I need to know. It tells me I need to be here at 13:40. It tells me what I'm doing next. It tells me everybody's name. It brings up I don't need to remember anyone's phone numbers anymore. So everything is, I'm being told everything. I'm mollycoddled. And we do actually, and will, lose our ability to remember, because the computer will be doing all of that for us. So that's an example of where we can use metadata, information about people, like LinkedIn, with augmented reality.
I think that's really why we're having this conference, to have all of these questions, and I don't think we're going to ever get any answers very quickly, but it just shows us that we're going to have a careful and considered approach, I think, for adoption of technologies into education as we go on. I'd like to extend a huge warm thank you again to Professor Paul Chapman. Thank you.